So my name is Muhammad Shami. I will tell about problem statement in digital attendance counter system. Problem statement: manual attendance recording system in classroom are inefficient and susceptible to errors such as duplicate attendance, incorrect counting, and time delay. In large classroom, lecturer may face difficulties monitoring attendance accurately within limited teaching time. Existing automated attendance system often depend on microcontroller or software-based solution, which may increase system complexity and cost. Therefore, there is for a simpler and more reliable attendance counting system that use only digital electronic component. The purpose digital attendance counter system aim to solve this issue by providing automated content mechanism using digital logic circuit. The system can accurately count student attendance, display the attendance number in real time, and automatically stop counting once the target number of students is reached. So for the next is objective. First, to design a digital counter system using digital electronic components only. Second, to develop a block diagram based on SSI digital circuit. Third, to stimulate the proposed circuit using suitable simulation software. 4. To display attendance number using BCD 7-segment display. 5. To compare the attendance counts with the selected target value using comparator circuit. 6. To automatically stop the counting process when the attendance reach the selected value. 7. To review a journal article related to digital system or digital attendance technology.
For our system, we have 7 main components. First, we have the 74LS147, which is a priority encoder. Its function is to translate target switches input into 4-bit BCD. And we have 74LS192, which is a synchronized counter. It tracks and counts live student attendance pulses. And we have the 74LS85, which is a magnitude comparator, and it triggers the auto stop mechanism when the target is reached. And we have the 74LS47, which is a BCD to 7-segment decoder, and it drives a visual numerical display of the 7-segment. We have the 74LS00 and 08, which they are the AND and NAND gates, who handles the control logic for system start, stop, and LED indicator. We also have 7-segment display to display attendance value, and finally LED indicator to show system active plus.
Moving on to the flowchart. Our system operates in 3 simple phases. First, system initialization, where the system is powered on. The lecturer sets the attendance target via switch S1 to S9 and press start to reset the counter and turn on the LED. Second, the attendance counting process, where each student's entry generates a pulse signals that increments the counter by 1 and display it in real time on the 7-segment display. And finally, the automatic stop function, where the system continuously compares the count to the target. If they don't match, it continues counting. But once the target is reached, the system automatically stops. The LED turns off and the process complete. Moving on to the block diagram. Our hardware system consists of 2 main input streams. First, the target attendance is set via the input target, processed through the priority encoder. and invert by the inverter before entering the 4-bit comparator. Second, the push buttons feed into the control logic which triggers the up counter to keep track of student interest. This current count is then set to both the 4-bit comparator for target matching and decode via the decoder to show real-time numbers on the 7-segment display. Finally, when a match occurs, the signal flows through the output control to activate or deactivate the LED indicator.
The slide shows the process simulation of our digital attendance counter system. First, the lecturer select the target attendance number using the selector switch and then press the start button. The counter reset to the 0. The LED turn on and system is ready to start counting attendance. Next, when the student check-in, this check-in generate a pulse signal. This pulse is sent to the BCD counter, causing the count value to increase by 1. The current attendance count is displayed on the 7-segment display. It allows the lecturer to monitor the attendance in real time. At the same time, the comparator continuously compares the current count with the target attendance value that was set earlier. This process happens automatically throughout the counting operation. And finally, when the current count reaches the target attendance value, the comparator sends a signal to stop the counting process. The LED indicator turns off. It shows the attendance target has been achieved. No further counting is allowed. Overall, the process simulation proved that the digital attendance counter system can count attendance accurately and stop automatically when the required attendance number is reached.
This is the result show that the student check-in system operate correctly in 4 different states. First, state 1, the target value is set using the switch. When the start button is pressed, a low pulse activates the system and turns on LED indicator. This confirms that the system is ready to operate. Second, state 2, the target value is set to 5 every time the student check-in button is pressed. The counter increases by 1. The display counts from 1 until 5, while the LED remains on, indicating that check-in are still allowed. For the third, state 3, when the counter reaches the target value of 5, the comparator detects that the count is equal to preset value. The comparator output change, causing the LED to turn off and preventing further counting. This proves that the limit control function works correctly. Okay, for the final state, which is state 4, when the reset switch is active, a high pulse is sent to reset a pin of the counter. The counter value is clear and returned to 0. The system is then ready for a new counting cycle. In conclusion, overall, the simulation successfully demonstrates that the system can start count student check-in, stop counting at preset limit, and reset correctly. That's all from me. Thank you.
For the journal review, we compared our project with a paper that also built an automatic counter using pure 74LS hardware without using any Arduino or coding. The main similarities is that we both using the 74LS 85 comparator chip. However, we use it differently. They use it to detect the direction of visitors using IR sensors, while we use it to check the left student count match the target limit. From this journal, we learn a critical hardware lesson. Unused pins cannot be left floating or they will cause error. This match our problem in process where we get the blue undefined lines, which we fix by properly connecting the start button to the master reset pin. In conclusion, the journal proved that pure hardware works, is cost-effective and secure from hacking. But the biggest challenges is messy wiring and sensitivity to outside noise. In conclusion, our digital counter project was successfully designed and tested using process. This project shows that we can make a classroom automation system by using pure hardware only, like the 74LS encoder, counter, comparator, and decoder chips. So we don't need to use any microcontroller or coding at all. From the simulation, the circuit function properly. It displays the count on the 7 segment and automatically stop counting when it hits the target number. Even though we had some early errors like undefined signal, we fixed it by setting up the circuit initialization properly. Overall, the project proved that classic digital logic is still very useful for real-world problems.